Hi students, in today's session we shall discuss about a very important trick, VBT trick for coordination compounds. So this type of questions you can expect in JEE mains and advanced NEET level competitive exams. So how to find geometry, hybridization and magnetic nature, and whether it is high spin complex or low spin complex if a coordination complex is given. How to find out these parameters for particular coordination complex. Okay, just by looking at the ligands and the oxidation state of the metal, we can find out its geometry, hybridization, and whether it is high spin or low spin complex, and outer orbital complex or inner orbital complex we can find out. So in this session I will give you a small trick. So first of all, if a coordination complex is given to you, you just find out the oxidation state of the central metal atom. Find oxidation state of the central metal atom. Central metal atom. Then second one, identify the type of ligand. Type of ligand. So whether it is strong field ligand or weak field ligand. Strong field ligand and weak field ligand, two types are there. Strong field ligands, example, NH3 ammonia is a strong field ligand, and cyanide ion Cn minus, and ethylene diamine En is a strong field ligand, NO2 minus, and nitrosyl NO. These are all the examples for strong field ligand. And weak field ligands, example, weak field ligands, F minus, Cl minus, Br minus, I minus, thiocyanide ion SCN minus or SCN, OH minus, H2O. These are all the examples for weak field ligand. Then how these ligands play an important role in the geometry or hybridization of the coordination complex. Let's take an example. CO F6 3 minus. So let's find out hybridization, geometry, magnetic nature, of the compound by taking this example. So in this example you can see here, as the cobalt is in +3 oxidation state, because here cobalt we need to find out, so X plus, so total 6 fluorines are there, 6, each fluoride ion contributes -1 charge, is equal to -3. So X minus 6 is equal to -3, X is equal to -3 plus 6, so is equal to +3. So what is the oxidation state of metal ion here? Metal, it is +3 oxidation state, CO in +3 oxidation state in this coordination complex. So what is the electronic configuration of cobalt in general? It is argon 3D 7 4s2 4p0 then 4d 0. So in this coordination complex, cobalt is in +3 oxidation state. So as it is in +3 oxidation state, 3 electrons will be removed from its original electronic configuration. So argon 3d 6, 4s 0, 4p 0, then 4d 0. How 3 electrons here? So 2 electrons from s orbital, then 1 electron from 3d level. So total 3 electrons are removed. So after removing 3 electrons, now it has 3d6 electronic configuration. So next, these 6 electrons will be arranged in d orbitals. 1, 2, 3, 4. So this is 3d level, 3d6, then 4s 0. After removing 3 electrons, I'm writing next 4p 0 and 4d also there. This is 4d 0. Okay. Now 6 electrons, 1, 2, 3, 4, 5, 6 electrons are entered like this, arranged like this. So now it is a very important point you have to keep in mind. Here fluorine is a weak field ligand. Fluorine is a weak field ligand. Weak field ligand. So in the presence of weak field ligand, pairing will not be taken place. Pairing will not be taken place in the presence of weak field ligand, because fluorine is a weak field ligand. So here there is no pairing of the electrons in 3d orbitals. So now we need to keep in mind it is an octahedral complex. Octahedral. Total coordination number of cobalt is what? Here 6 is the coordination number. So 6th coordination number means it is an octahedral complex compound. Octahedral complex. So octahedral complex means either it has sp3dt d2 configuration or d2 sp3 hybridization. Sorry, sp3d2 or d2 sp3 hybridization involves in this coordination compound, because it has its coordination number is 6. So hybridization either will be sp3d2 or d2 sp3. If the electrons will be paired in the presence of strong field ligand, so d electrons from 3d level will be used, will be participated in hybridization. But it is a weak field ligand. In the presence of weak field ligand, hybridization is not electron pairing is not taking place. So that is why outer orbitals will be used here. So it means 1s orbital, then 3 p orbitals and 2 d orbitals. So total sp3 d2. So 1s orbital and 3 p orbitals and 2 d orbitals. So total sp3 d2 hybridization in this complex compound. In this complex compound, what is the hybridization? sp3 d2 hybridization is the hybridization in this compound. sp3 d2 hybridization, because it is outer orbital complex, OOC, outer orbital complex, because outer orbitals are using in this coordination compound. Okay. So now this is 3d level, T4, then this is 4s, and this is 4p, and this is 1, 2, 3, 4. So this is 3d, 6, 4s 0, 4p 0, then 4d 0. So total here, how many fluorines are present in this coordination compound? So total 6 fluoride ions are present. So each fluoride ion will be donating a pair of electrons to these vacant orbitals. So total 6 fluoride ions. So electron pairing here taking place. So total sp3 d2. sp3 d2 hybridization. So total how many hybrid orbitals? 6 sp3 d2 hybrid orbitals are present in this metal. Okay, in this metal. So total how many? 6 sp3d2 hybrid orbitals are present. So these 6 sp3d2 hybrid orbitals now bonding with fluoride ions. Each sp3d2 hybrid orbital is bonding with fluoride ion. So what is the hybridization? sp3d2 hybridization and structure of 1 2 3 4 5 6. So structure is what here? Chlorine, chlorine, so 3 minus. So this is the structure of this compound coordination complex. And here hybridization is what in this compound? Hybridization is sp3 hybridization is sp3d2. Then geometry is what here? Geometry octahedral geometry, as its coordination number is metal coordination number is 6. It is an octahedral complex. Then magnetic nature is what? Magnetic nature, as it has a metal atom containing lone pair of electron, unpaired electrons, sorry, metal atom contain unpaired electrons. It is a paramagnetic substance. It is paramagnetic substance. Paramagnetic substance it is. And it is outer orbital complex. Outer orbital complex, as there are unpaired electrons. Unpaired electrons, it is high spin complex. High spin complex. So like this, you can solve any coordination complex compound. Just you have to keep in mind whether the ligand is strong field or weak field ligand. So we can solve one more example depending upon this trick. Another compound is CO NH3 6 3 plus. So find out geometry, hybridization, and magnetic nature. Let's find out. So here in this complex compound, ammonia is a neutral ligand. So this will be the this will be the oxidation state. So this 3 plus is the oxidation state for the metal. So here CO, argon, 3D7, 4S2, 4P0, then 4D0. So in this coordination complex, CO is in +3 oxidation state. So argon, 3D6, 4S0, then 4P0, 4D0. Okay. Then next filling of the electrons will be into atomic orbitals. 3D6 it is. Then this is 4S0, 4P0, 4D0. So 1, 2, 3, 4, 5, 6. So this is the electron arrangement. So up to this same, but here you have to keep in mind. So here ammonia is a strong field ligand. NH3 amine is a strong field ligand. So in the presence of strong field ligand, so here pairing will be taken place. Electrons will be paired in the presence of strong field ligand. 1, 2, 3, 4. So similarly here electrons. So total electrons, 6 electrons will be getting paired. 1, 2, 3, 4, 5, 6. So this is the very important step here. This is 4s0, same. Then it is 4p0. Then this is 4d0, and this is 3d6. You have to keep in mind. So here, this is the very important step. So because amine is a strong field ligand, that is why all the electrons are getting paired in the presence of strong field ligand. So now what is the hybridization? Here there are two vacant orbitals in 3D level. So these two orbitals will be now participated in hybridization. Okay. So that is why here 2d orbitals. So it is ammonia is a cobalt hybrid coordination number is what? 6 is the coordination number. So structure will be octahedral, definitely. Structure will be, geometry will be octahedral, and hybridization either D2sp3 or sp3 D2 will be involved. So here D2sp3, when it will be involved, whenever the inner orbitals are used or participated or involved in hybridization, then such a case hybridization will be D2sp3. So here total 2 d orbitals are vacant now. So these two orbitals will be participated, involved. 2 d orbitals D2sp3. So these are not involving now. These are not involving in hybridization. Only two d orbitals D2, 1 s orbital, then 3 p orbitals. So D2sp3 is the hybridization here. This is the very important step. So in this one, what is the hybridization? D2sp3. Hybridization is D2sp3 hybridization. Then geometry will be octahedral. Same, geometry will be octahedral. And magnetic nature. So this is very important. So here there are no unpaired electrons. Understand? Because in the presence of strong field ligand, electrons getting paired. So no unpaired electrons are present in 3D level. Here you can see 3D level, all the electrons got paired. So 1, 2, 3, 4, 5, 6. So here there is no unpaired electron. So that is why it is a diamagnetic substance, not paramagnetic. If unpaired electrons are present, then it will be definitely paramagnetic, but there is no unpaired electron. That is why it is a diamagnetic substance, diamagnetic coordination complex. And inner orbital, IOC, inner orbital complex, as there are no unpaired electrons, so it is a low spin complex, low spin complex, because there is no unpaired electron. That is why it is a low spin complex. So like this, you can find out geometry, hybridization, and the magnetic nature of any coordination complex compound depending upon the nature of the ligand. You have to keep in mind whether it is strong field ligand or weak field ligand. Depending upon the nature of the ligand, electrons will be getting paired or electrons will not be getting paired. If the electrons are getting paired in the presence of strong field ligand, then hybridization will be D2sp3. Then it will be inner orbital complex compound, diamagnetic nature, and it is a low spin complex. Okay, if the electrons are not getting paired, then outer orbitals will be used. So in such case, hybridization will be sp3d2, then geometry will be octahedral, then outer orbital complex compound, high spin complex, as there are unpaired electrons. So this is the trick for VBT trick for the coordination complex compound. Students, if you like this video, just give a thumbs up for the video and subscribe to my channel for more chemistry concept videos. Thank you for watching.